Welcome back to CVM X. If you're preparing for a data analyst role in the era of artificial intelligence, this video is your ultimate guide. We'll walk through 200 realistic interview questions and answers tailored for analysts working with AI projects, covering fundamentals, data quality, feature engineering, monitoring, fairness, and real-world case studies. Whether you're applying at Google, Microsoft, Amazon, or a fast-growing startup, this is the most comprehensive prep you'll ever need. Let's dive in. What is the role of a data analyst in AI projects? A data analyst ensures that the data feeding AI systems is accurate, representative, and aligned with business goals. They explore, validate, and monitor data sets to make sure AI models are built on strong foundations. What types of data are commonly used in AI? AI uses structured data, tables, logs, unstructured data, text, audio, video, and semi-structured data, JSON, XML. Analysts prepare these formats for training and evaluation. How do training, validation, and test datasets differ? Training data teaches the model. Validation data tunes parameters and prevents overfitting. Test data evaluates final performance on unseen cases. Why is data labeling important in AI? Labels give meaning to input data, like tagging emails as spam or not spam. Without accurate labels, supervised learning models can't learn effectively. What is the difference between raw data and features in AI? Raw data is unprocessed, while features are meaningful variables derived from it. For example, raw clickstream logs can be transformed into features like time spent on page. What does garbage in, garbage out mean in AI? It means poor quality data leads to poor quality AI models. If the input is biased, incomplete, or noisy, the model's predictions will also be unreliable. Why is representativeness of data critical in AI? If the training data doesn't represent the real-world population, the AI will make biased or inaccurate predictions. For example, a face recognition model trained mostly on one ethnicity won't generalize well. What is data annotation in AI? It's the process of tagging or labeling raw data, like marking objects in images or assigning sentiment to text. Analysts ensure annotation quality and consistency. What is the role of exploratory data analysis, EDA, in AI projects? EDA helps identify missing values, imbalances, outliers, and trends in data before training models. It ensures that the data pipeline produces reliable inputs. Why are large data sets often needed in AI? Because AI models, especially deep learning, require many examples to learn complex patterns. Small data sets often lead to underfitting or unstable predictions. How does data imbalance affect AI systems? Imbalance, example, is 95% healthy versus 5% disease patients, makes models biased toward the majority class, leading to poor detection of rare but important cases. What is the difference between structured and unstructured data in AI? Structured data is organized in rows and columns, easy to query. Unstructured data like images, audio, and text needs pre-processing to extract useful features for AI. Why is domain knowledge important for data analysts in AI? Domain expertise helps analysts identify meaningful features, detect anomalies, and interpret results in business context, ensuring AI solutions are relevant and actionable. What is a feature in AI? A feature is a variable used as input to train a model. For example, age, income, or click-through rate. Strong features improve model accuracy. What is feature representation in AI? It's how raw inputs are transformed into machine-readable variables. For instance, text can be represented as word embeddings instead of raw words. What are the risks of using historical data in AI? Historical data may carry past biases, outdated patterns, or irrelevant trends. This can cause AI to perpetuate unfairness or make poor predictions in current context. What is the difference between supervised and unsupervised data from an analyst's perspective? Supervised data has labels, example is spam versus not spam, requiring quality checks on annotations. Unsupervised data lacks labels, so analysts focus on clustering patterns and distributions. How do you ensure data quality in AI pipelines? By validating completeness, accuracy, consistency, and timeliness of data. Analysts run checks on duplicates, outliers, and missing values before feeding it into models. What is metadata, and why is it important in AI datasets? Metadata describes data properties, like collection time, source, or units. It helps track lineage, improve reproducibility, and ensure correct interpretation of datasets. What is the role of synthetic data in AI? Synthetic data is artificially generated to augment training sets, balance classes, or simulate rare events. Analysts evaluate its validity before use. How does bias enter AI datasets? Bias can arise from unrepresentative samples, collection methods, labeling errors, or social and cultural influences embedded in data. What are ground truth labels in AI? Ground truth refers to the most accurate reference labels used to evaluate AI predictions. It's the gold standard against which models are judged. Why is version control of data important in AI? As data changes over time, versioning ensures traceability. Analysts can reproduce results and compare model performance across different dataset versions. How does feature scaling impact AI models? Scaling ensures that features with large ranges, like income, don't dominate smaller ones like age. It improves model performance and stability. What is the role of a data analyst in bridging AI in business? Analysts translate raw model outputs into actionable insights for stakeholders, ensuring AI predictions align with real-world goals and add measurable value. What does data quality mean in AI, and why does it matter? In AI, data quality is about whether the information feeding a model is accurate, complete, consistent, timely, valid, and deduplicated. Models don't reason beyond their inputs, so quality directly sets the ceiling on performance. Poor quality data can create spurious correlations, amplify bias, and cause brittle behavior in production. High-quality data, by contrast, raises signal-to-noise ratio, stabilizes training, improves generalization, and reduces downstream costs like manual triage. In short, garbage in, garbage out isn't a cliché in AI, it's physics. Which dimensions of data quality are most critical for AI systems? The classic six are accuracy, completeness, consistency, timeliness, validity, and uniqueness. For AI, I'd add representativeness. Does data reflect real users? And label fidelity. Are targets reliable? Accuracy prevents false patterns. Completeness avoids selection bias. Consistency aligns schemas across sources. Timeliness combats drift. Validity enforces ranges and formats. Uniqueness removes duplicates that inflate confidence. Representativeness ensures fairness and generalization, while label fidelity is essential for supervised learning. Together, these dimensions define a defensible training set. How do you ensure data lineage and provenance in AI datasets? I document where the data came from, how it was collected, when, under what policies, and every transformation applied. Practically, that means a dataset manifests with source systems, extraction logic, filtering rules, and version hashes for raw and processed artifacts. Provenance ties samples back to origin for auditability and reproducibility, and helps diagnose regressions when performance shifts. It also supports compliance. If a jurisdiction or consent status changes, lineage tells you which rows or labels must be purged or reprocessed. How do you manage label quality in supervised AI? I start with a clear labeling guideline, pilot it on a small batch, and compute inter-annotator agreement to spot ambiguity. I use consensus mechanisms. Example is multiple independent labels with adjudication for tough cases, and maintain gold sets to continuously calibrate raters. I also review error heat maps by class and subgroup to catch systemic confusion. Finally, I track label drift over time. Definitions evolve, and if labels shift unnoticed, model performance appears to drop when the target moved. How do you handle missing data in AI, MCAR, MAR, MNAR? First, I diagnose the mechanism. MCAR, missing completely at random, is benign. Simple imputation or row dropping can work. MAR, missing at random, requires conditioning on observed variables, stratified imputation or model-based approaches. MNAR, not at random, is dangerous because the missingness carries information. I'll create indicator features, consult domain experts, and consider targeted data collection. Across all cases, I quantify impact via sensitivity analysis and avoid imputations that leak target information. How do you address class imbalance without introducing bias? I start by measuring prevalence and evaluating with recall, precision, and F1 rather than accuracy. Options include resampling, careful up or down sampling, cost-sensitive thresholds, and stratified splits so minority patterns appear in validation. I'll add group-aware checks to ensure fixes don't harm protected subpopulations. Critically, I pair any resampling with leakage guards, no duplicates across splits, and run calibration checks. Otherwise, the classifier may look good on paper, but fail with real-world priors. How do you treat noisy labels and outliers in AI data? I quantify noise via disagreement rates and compare model errors against gold sets. For labels, I may reannotate edge cases, apply confidence weighting, or filter low agreement items. For outliers, I distinguish errors, fix or remove, from rare but real events, like retain, maybe reweight. I examine influence. Do a few points disproportionately change the decision boundary? Finally, I document decisions so future retraining doesn't accidentally reintroduce harmful noise. How do you check if a dataset is representative of the target population? I compare dataset distributions to population benchmarks across key variables: geography, device, language, tenure, and critical demographics where, legally and ethically appropriate. I look for coverage gaps and covariate shift between training and deployment environments. If gaps exist, I plan targeted data collection, stratified sampling, or reweighting during evaluation. I also validate performance across subgroups. A model that's great on average but fails for a segment is not representative in practice. What is data leakage and how do you prevent it? Leakage is when information from the future or target sneaks into training features, inflating offline metrics and collapsing in production. Prevention is procedural. Time-aware splits, row-level deduplication across splits, and strict feature vetting to remove proxies of the label. I also audit pipelines for post-event features, e.g. refund amount when predicting fraud, and run sanity tests like randomizing labels to ensure performance drops, proving the model isn't exploiting leakage. How do you design, train, validation, and test splits for real-world AI? I prefer temporal splits for time-dependent systems, ensuring validation simulates the future. I use stratification to preserve class ratios and entity-aware splitting so users or items don't appear in both train and test. For rare events, I ensure the test has sufficient positive cases to be statistically meaningful. Finally, I fix a frozen test set and version it. Changing the yardstick mid-project makes comparisons meaningless. What practices ensure reliable ground truth in AI evaluations? I define tight labeling rubrics, build gold standard items, and measure rater calibration periodically. For subjective tasks, I use multi-rater consensus and capture rationale notes for tough calls. I maintain a living taxonomy. If categories evolve, I migrate historical labels with clear mapping. I also separate development and evaluation gold sets to prevent overfitting to the test. Ground truth is a product. It needs governance, versioning, and audits. How do you implement data validation in AI pipelines? I enforce schema checks, like types, nullability, range and constraint checks, example age greater than or equal to 0, cross-field logic, start time less than end time, and distribution guards, means, mins, maxes within expected bands. I track duplication rates and label distribution drift. Each check logs metrics and fails fast with actionable errors. Crucially, I separate hard stop safety or compliance from soft alerts monitoring, so the system is both protective and resilient. How do you monitor data drift after deployment? I baseline feature distributions from training and continuously compare production feeds. I watch summary stats, category frequencies, and distance or shift metrics to detect movement. When thresholds trigger, I investigate. Is it seasonal, a product change, or an upstream pipeline issue? I pair drift with performance telemetry. Drift without harm might be benign, but drift plus metric decay is a retraining signal. Every alert is logged, triaged, and either fixed or accepted with rationale. Distinguish data drift, concept drift, and label drift. Data drift, inputs change. Example is new device mix, while the mapping may still hold. Concept drift, the input-output relationship changes. Fraudsters adapt. So yesterday's patterns no longer predict today. Label drift, the prevalence of classes shifts. Spam rate doubles. In practice, I monitor all three: input distributions, model residuals, and target rates. The remediation differs. Data drift may need rebalancing. Concept drift needs new features or strategy. Label drift often needs threshold recalibration. How do you detect and handle label drift in production? I track positive rate over time and compare it to historic bands, adjusting for seasonality. If ground truth arrives with delay, I use weak signals, user actions as early indicators, and reconcile later. Mitigations include threshold tuning, recalibration, or incremental retraining with recent data. I also communicate the business meaning. A higher positive rate may be a real surge, not a model fault. The goal is to separate signal from data process artifacts. What are the risks and benefits of synthetic data for AI? Synthetic data can balance rare classes, protect privacy, and speed iteration. Risks are distribution mismatch, models learn synthetic artifacts, label shortcuts if generation is simplistic, and false confidence when performance is measured on data similar to what was generated. My approach: validate synthetic examples against real-world statistics, keep proportions modest, and always evaluate on real holdouts. Synthetic data augments. It shouldn't replace genuine, representative samples. How do you protect privacy while preserving data utility? I minimize collection to what's necessary, anonymize direct identifiers, and reduce quasi-identifiers via aggregation or generalization. I adopt purpose limitation. Features shouldn't outlive their use. I also assess re-identification risk when joining datasets and prefer privacy-preserving summaries over raw logs for analysis. Throughout, I document consent, retention, and deletion policies. The test is simple. Would a reasonable user be surprised by this use of their data? What does data freshness mean, and why is it crucial for AI? Freshness is the latency between real-world events and data availability for the model. In dynamic domains, recommendations, fraud, ops, stale data silently degrades performance and trust. I define SLAS for arrival times, monitor lag distributions, and establish fallback behaviors when feeds run late. Freshness also interacts with drift. Slow pipelines hide real distribution shifts until they hit you all at once. Keeping data current is a competitive advantage. Which quantitative quality metrics do you track for AI datasets? I maintain a quality scorecard: missingness rates, duplicate rates, invalid value counts, outlier rates, label agreement, class prevalence, distribution shift metrics, and coverage across key segments. I also track data debt, known issues with owners and timelines. Each metric has thresholds, trend lines, and runbook actions. By making quality visible and numeric, teams can prioritize fixes and correlate data improvements with model gains. How do you approach data quality for multimodal AI text, image, audio? I tailor checks by modality: text, language detection, profanity or PI filters, token length sanity; images, resolution, aspect ratio, blur or occlusion flags, deduplication; audio, sampling rate consistency, background noise levels, clipping detection. Across all, I enforce label alignment and metadata completeness: device, locale, capture conditions. I also create balanced evaluation slices per modality condition. Examples are low-light images or accented speech, to ensure the model doesn't only work in perfect lab scenarios. How do you guard against adversarial or spammy data corrupting AI? I instrument ingestion filters, enforce rate limits, and look for behavioral fingerprints like repetitive patterns, unusually uniform values, or bursty submissions. I maintain block lists or allow lists where appropriate and run periodic audits against gold sets to catch subtle degradations. For user-generated content, I add pre-screening heuristics, and require diversity in sources so one actor can't dominate the data set. Defense in depth matters. No single rule will catch everything. What is human in the loop, HITL for data quality, and when is it essential? HITL blends automated checks with expert review for ambiguous or high-impact cases. Think medical triage, safety, or policy enforcement. It's essential when context is hard to encode or the cost of error is high. I design escalation queues, define SLAS for review, and feed reviewer decisions back as training signal. Over time, HITL focuses on the hardest 5 to 10%, while automation covers the rest, improving both quality and efficiency. How do you document datasets so teams can use them responsibly? I ship a dataset card that states purpose, collection methods, time window, known gaps, pre-processing steps, label definitions, intended use, out-of-scope uses, and evaluation slices. I include ethical considerations, consent context, and maintenance plans. Good documentation prevents misuse, speeds onboarding, and makes deprecations orderly instead of chaotic. It's also the first thing auditors and partners ask for when stakes are high. How do you ensure pre-processing is reproducible and doesn't hide quality issues? I keep declarative, version transforms with checksums for inputs or outputs, and I log pre- and post-transformation statistics to prove we didn't clean away the signal. Any imputation or normalization is parameterized and recorded. I run A/B evaluations of pre-processing changes against frozen tests to confirm they help. Finally, I make raw data accessible with guardrails so analysts can trace anomalies back to source without guesswork. How do you vet third-party or external data for AI use? I assess license, consent, and compliance first. If you can't lawfully use it, quality is moot. Next, I test coverage and bias against our target population, validate label reliability, and run pilot integrations to measure real model lift. I also stress test lineage transparency and update cadence. Black box feeds with unknown refresh cycles are a risk for drift. Any adoption includes monitoring hooks and an exit plan if quality degrades. What is the role of EDA in AI projects? EDA helps us understand the data before modeling, its distributions, relationships, and anomalies. In AI, this means spotting skewed classes, mislabeled data, or unfair subgroup patterns that could bias models. Without EDA, we risk training blindly on poor data, producing untrustworthy outputs. How do you detect class imbalance during EDA? I'd start with frequency counts and visualizations like bar charts to see class ratios. Then I check if imbalance is consistent across subgroups. Sometimes one group is more underrepresented. This early detection shapes decisions on resampling, threshold tuning, or collecting more data. How do you spot bias in datasets during EDA? Bias appears when certain groups are underrepresented or misrepresented. I'd analyze distributions across demographics, geographies, or devices, then compare outcomes across them. If error rates or sample counts differ sharply, that's a bias signal needing mitigation. How do you detect outliers in AI datasets? I use statistical thresholds like z-scores or IQR, combined with visual tools like box plots or scatter plots. But I also ask, is it an error or a rare but important case? Outliers in AI can be either noise or critical edge cases the model must learn. How do you decide whether to remove or keep outliers? If outliers are due to errors or impossible values, I'll remove or correct them. But if they represent real but rare events, like fraud transactions, they're valuable for training. Context and domain knowledge drive the decision. What's the impact of skewed features on AI models? Highly skewed features can mislead models, making them biased toward extreme values. For example, income data is often skewed. Transformations like log scaling or binning during EDA help models learn patterns more fairly. How do you detect skewness in features? I'd compare mean versus median, calculate skewness statistics, and visualize distributions with histograms. Strong differences show skew. Recognizing skew is critical before applying scaling or transformations. How do you check correlations between variables in AI datasets? I use correlation matrices or heat maps for numerical variables and chi-square tests for categorical relationships. Strong correlations may signal redundancy, multicollinearity, or proxy bias, which could weaken model stability. What is multicollinearity, and why does it matter in AI? Multicollinearity is when input variables are highly correlated, making it hard to separate their individual effects. In AI, this can inflate feature importance, destabilize coefficients, and add noise. Detecting it in EDA helps decide whether to drop or combine features. How do you uncover hidden bias through EDA? I check performance metrics or distributions across slices. For example, prediction errors by gender or region. Bias often hides in subgroups, not in averages. Slice-based EDA surfaces these fairness gaps before deployment. How do you validate data representativeness with EDA? I compare dataset distributions against known population statistics, like census data or business KPIs. If the dataset misses key segments, the model won't generalize. This step ensures data mirrors the reality we want AI to serve. How do you detect mislabeled data during EDA? I cross-check samples with domain rules, review edge cases, and sometimes use simple baseline models to flag suspicious labels. If a cat image looks visually different from others in the class, that's a mislabel to review. How do you examine interactions between features in EDA? I plot scatter plots, grouped box plots, or cross-tabulations to see how variables behave together. Interactions often explain more variance than single features. For example, age times income may predict purchase behavior better than either alone. How do you evaluate missingness patterns during EDA? I check if missing values are random or systematic. If only high-income users skip income fields, that's systematic and could bias AI models. Visuals like heat maps of missingness help detect patterns. Why is subgroup analysis important in AIEDA? Because models often perform well on average but poorly for minorities. By slicing data by subgroup, analysts ensure performance equity, fairness, and avoid harmful biases in AI systems. How do you visualize imbalances during EDA? Simple bar charts for categorical data and density plots for continuous data make imbalances obvious. For multi-class problems, confusion matrix-style visuals show which categories dominate or lag. What role do summary statistics play in AIEDA? They give a quick snapshot of central tendency and spread, mean, median, variance, helping to flag anomalies. For AI, I especially watch variance. Low variance features add little value to learning. How do you detect label imbalance in EDA? By analyzing target variable frequencies. If one class overwhelms others, it signals imbalance. For example, 95% not spam versus 5% spam emails means models could ignore spam unless addressed. What is correlation versus causation in EDA for AI? Correlation shows association, but causation means one variable influences another. AI models trained only on correlations risk spurious links. Analysts must guard against misinterpreting patterns as causes. How do you test for proxy variables in EDA? Proxy bias happens when variables indirectly encode sensitive attributes. For example, ZIP codes may proxy for race. I test correlations with sensitive fields and check subgroup performance gaps to detect hidden proxies. How do you examine temporal trends during EDA? I plot time series of features and labels to see seasonality, drift, or sudden shifts. This is key for AI, since models trained on old patterns may fail as reality changes. What is residual analysis in AIEDA? Even before full modeling, I run simple baseline models and analyze residuals. If errors cluster in specific groups or ranges, that signals bias or underrepresentation in training data. How do you validate that EDA findings are statistically significant? I use hypothesis testing t-tests, chi-square, ANOVA to confirm patterns seen in visuals aren't random. This ensures we don't overreact to noise in AI data. What is an example of using EDA to detect bias in real-world AI? In a hiring dataset, EDA might show men and women are equally represented, but promotions skew male. That hidden imbalance, if uncorrected, would bias an AI promotion recommender. How do you communicate EDA findings to non-technical stakeholders? I avoid jargon, use clear visuals, and frame insights in terms of business risk. For example, if we deploy this model now, it may misclassify customers in rural areas since they're underrepresented. What is feature engineering in the context of AI? Feature engineering is the process of transforming raw data into meaningful inputs that improve model performance. For example, turning a timestamp into features like day of week, hour, or holiday flag. Well-engineered features often contribute more to model success than algorithm choice itself. Why is feature engineering critical for AI models? Because AI models can't always extract meaning directly from raw data. Carefully engineered features capture domain knowledge, context, and signal, helping models generalize better. In practice, and strong features can reduce overfitting and improve interpretability. What are categorical variables, and how are they treated in AI? Categorical variables are non-numeric labels like region or gender. They're often transformed into numeric representations using one-hot encoding, label encoding, or embeddings. The method depends on whether categories are nominal, ordinal, or very high cardinality. What are numerical transformations in feature engineering? These include normalization, standardization, log transforms, and binning. For example, income is often log transformed to reduce skew. These adjustments stabilize learning and prevent large-scale features from dominating models. How do you create time-based features for AI? By extracting components like hour, weekday, month, or season. More advanced features include time since last event, rolling averages, or trend slopes. These capture seasonality and temporal patterns critical in domains like finance or e-commerce. What are interaction features and why use them? Interaction features combine two or more variables, like age times income for purchasing power. They reveal relationships that individual variables can't capture, improving model accuracy and interpretability. What is binning and when is it helpful? Binning groups continuous variables into categories. For example, grouping ages into ranges, 18 to 25, 26 to 35. It reduces noise, captures nonlinear effects, and improves interpretability for certain AI models. What is feature scaling, and why is it necessary? Scaling ensures variables are on comparable ranges. Without it, features with larger scales like salary can dominate smaller ones like age. Scaling improves stability, especially for models sensitive to magnitude, like neural networks or logistic regression. How do embeddings improve feature representation? Embeddings map high-dimensional categorical data, like words or items, into dense vectors that capture similarity and relationships. In AI, embeddings are powerful because they encode semantic meaning beyond simple one-hot encodings. What is dimensionality reduction, and why is it used in AI? It's the process of reducing the number of variables while preserving key information. Techniques like PCA or autoencoders help eliminate redundancy, improve efficiency, and reduce overfitting in AI models. How do you handle high cardinality categorical features? I might group rare categories, use frequency encoding, or apply embeddings. For example, instead of one-hot encoding millions of ZIP codes, embeddings can capture similarity across them without exploding dimensionality. What is feature selection, and how does it differ from feature engineering? Feature engineering creates new variables, while feature selection chooses the most relevant ones from the pool. Selection prevents overfitting, reduces computation, and ensures models focus on meaningful signals. How do you detect redundant features during analysis? By checking correlation matrices, variance inflation factors, or feature importance scores. Highly correlated or low variance features are candidates for removal. Reducing redundancy improves efficiency and model clarity. What is target leakage, and how does it relate to feature engineering? Target leakage occurs when features contain information about the outcome that wouldn't be available in production. For example, including fraud refund amount when predicting fraud. Leakage inflates metrics during training, but fails in real use. How do you engineer features for text data? By extracting counts, bag of words TF-IDF, sentiment scores, keyword flags, or embeddings like word2vec and BERT. The choice depends on complexity. Simple counts may work for basic tasks, embeddings for nuanced meaning. How do you engineer features for image data? Options include color histograms, edge detection outputs, or pre-trained CNN embeddings. Analysts usually pre-process images, resize, normalize, before extracting features for downstream AI models. How do you engineer features for time series data? I create lag features, moving averages, rolling statistics, seasonality indicators, and trend slopes. These transformations highlight temporal dependencies, crucial for forecasting and anomaly detection. What is feature encoding and why is it used? Encoding converts categorical variables into numeric form. Options include label encoding, one-hot encoding, binary encoding, or embeddings. Encoding ensures that models can process categories mathematically. What is feature importance and how do analysts use it? Feature importance measures each variable's contribution to predictions. Analysts use it to select relevant features, drop noisy ones, and explain model behavior to stakeholders. How do you engineer ratio-based features and why are they powerful? By dividing one metric by another, like sales per customer or clicks per impression. Ratios often normalize for scale and highlight efficiency, making them more meaningful than raw values. What is polynomial feature engineering, and when is it used? Polynomial features are created by raising variables to powers or combining them multiplicatively. They help capture nonlinear relationships, though they must be used carefully to avoid overfitting. How do you handle imbalanced features in AI datasets? By reweighting categories, grouping rare values, or engineering features that highlight minority patterns. For example, creating is-high-risk flags can help models pay attention to rare but important cases. How do you validate the usefulness of engineered features? I run EDA correlations, feature importance scores, and model performance comparisons with and without the feature. If it consistently improves accuracy or interpretability, it's valuable. Can you give an example of domain-specific feature engineering in AI? In fraud detection, features like time since last transaction or transaction location change are highly predictive. They embed domain knowledge into model-ready variables. How do you balance automated versus manual feature engineering? Automation tools generate large numbers of features, but manual engineering adds domain insight. The best approach combines both. Automated feature extraction for scale, plus human-driven design for relevance and interpretability. Why is model evaluation critical from a data analyst perspective? Because evaluation tells us if the AI model actually solves the business problem. A data analyst ensures metrics are correctly calculated, aligned with business goals, and not misleading. Without strong evaluation, even technically accurate models may fail in real-world use. What is a baseline model and why is it important? A baseline is a simple benchmark, like predicting the majority class or average. It sets a floor for performance. If a complex AI model can't beat the baseline, it's not adding value. Analysts use baselines to keep expectations grounded. How do you choose evaluation metrics for AI models? The choice depends on the problem and business goals. For fraud detection, recall matters more. For spam filters, precision is critical. A data analyst matches the metric to the cost of errors, not just overall accuracy. Why is accuracy sometimes a misleading metric? In imbalanced datasets, accuracy can look high even if the model fails on minority cases. For example, predicting not fraud 99% of the time achieves 99% accuracy but misses fraud. Analysts check precision, recall, and F1 instead. How do you explain precision and recall to a business stakeholder? Precision answers. When the model says yes, how often is it correct? Recall answers. Out of all the real yes cases, how many did the model catch? It's like precision is about quality. Recall is about coverage. What is the F1 score and why is it useful? F1 is the harmonic mean of precision and recall. It balances both metrics, making it especially useful when classes are imbalanced and we care about avoiding both false positives and false negatives. How do you evaluate regression models differently from classification models? For regression, we measure continuous errors using metrics like RMSE, MAE, or R-squared. For classification, we use accuracy, precision, recall, and F1. Analysts choose the right metric to reflect the type of prediction. What is residual analysis and why is it important? Residuals are the differences between predicted and actual values. If residuals are random, the model is good. But if patterns remain, it means the model missed some structure. Analysts use this to improve features or detect bias. What is calibration in model evaluation? Calibration checks if predicted probabilities reflect reality. If a model says 70% chance, that event should happen about 7 out of 10 times. Poor calibration makes probabilities unreliable for decision-making. What is ROC curve and how do you interpret it? The ROC curve plots true positive rate versus false positive rate at different thresholds. A curve closer to the top left is better. It shows how trade-offs shift as we adjust thresholds. What is AUC and why is it important? AUC, area under curve, is a single number summarizing the ROC curve. AUC of 0.5 means random guessing, while 1.0 means perfect. It's important for comparing models consistently. How do you evaluate models in the presence of class imbalance? I look beyond accuracy, focusing on precision, recall, F1, and AUC. I also check confusion matrices to see where the model fails, ensuring minority classes are not ignored. What is a confusion matrix, and how does it help in evaluation? It's a table showing true versus predicted classes. It helps analysts see exactly where errors occur, false positives, false negatives, etc. It's more informative than a single metric. Why is business context essential in choosing evaluation metrics? Because the cost of errors differs by scenario. In healthcare, missing a disease case is far worse than a false alarm. Metrics must reflect those stakes, not just mathematical performance. How do you detect overfitting during model evaluation? By comparing performance on training versus validation or test sets. If training accuracy is much higher, the model memorized data instead of learning patterns. Analysts flag this for correction. How do you use cross-validation in evaluation? Cross-validation splits data into multiple folds, training and testing on each. It reduces the risk of overestimating performance from a lucky split, giving more reliable evaluation. What is error analysis and why is it powerful? Error analysis means examining model mistakes, not just overall scores. Analysts categorize errors by type or subgroup, uncovering blind spots like poor performance for certain demographics. How do you evaluate fairness in AI models? By checking whether metrics like precision and recall are consistent across subgroups, for example, gender, age, region. Disparities signal bias that must be addressed. What is the role of thresholds in evaluation? Thresholds control the trade-off between precision and recall. Analysts test different cutoffs to align model outputs with business needs. For example, stricter thresholds in fraud detection. How do you evaluate models over time? By monitoring metrics across different time windows. Performance may decay due to data drift or changing user behavior. Trend analysis ensures evaluation is not just a one-time event. Why is explainability part of evaluation? Because stakeholders need to trust the model. Analysts evaluate not only accuracy, but also whether the model's drivers make sense. Explainability tools help confirm alignment with domain logic. How do you evaluate model robustness? By testing performance under stress, noisy inputs, edge cases, or shifts in data. A robust model should maintain stability, not collapse when data deviates slightly. What is out-of-sample evaluation and why is it critical? It tests models on data never seen during training or tuning. It simulates real-world conditions, ensuring the model generalizes instead of memorizing. How do you evaluate models in multi-class problems? I use metrics like macro or micro F1, per-class precision and recall, and confusion matrices. Evaluating across all classes ensures the model isn't favoring only the majority. What is the data analyst's role in post-deployment evaluation? Analysts monitor inputs, outputs, and metrics over time, flagging drift or degradation. They ensure evaluation is continuous, keeping AI systems aligned with reality and business goals. Why is monitoring AI systems important after deployment? Models don't fail loudly. They degrade quietly. Monitoring ensures we track input quality, output accuracy, and business KPIs over time. Without monitoring, drift or errors can persist unnoticed, hurting trust and performance. What is data drift and why is it a problem? Data drift is when input distributions change compared to training data. For example, new customer behaviors may not match historical data. Drift reduces model reliability, leading to poor predictions if not addressed. What is concept drift and how does it differ from data drift? Concept drift means the relationship between inputs and outputs changes, even if input distributions don't. For example, fraudsters adapting their strategies. Unlike data drift, it requires model retraining, not just data fixes. What is label drift and how do you detect it? Label drift occurs when the target class distribution shifts. For example, spam rate rising from 5% to 20%. I detect it by tracking label frequencies and comparing them over time, adjusting thresholds or retraining when shifts are significant. How do you monitor AI inputs in production? I track statistics like means, medians, ranges, and category frequencies, then compare them to training baselines. Alerts trigger if deviations exceed thresholds, signaling potential drift or pipeline issues. What is the role of performance monitoring in AI governance? Performance monitoring ensures models meet accuracy, fairness, and stability targets. Governance frameworks require regular audits, documentation, and transparent reporting to stakeholders. How do you set thresholds for drift detection? Thresholds are based on historical variability and business tolerance. For example, a plus or minus 5% swing in customer demographics may be acceptable, but a 20% drop in precision is not. Thresholds are defined collaboratively with domain experts. What is a model monitoring dashboard and why is it important? It's a central interface showing key metrics like accuracy, drift indicators, input stats, and subgroup performance. It provides early warnings so issues are caught before they harm business operations. How do you measure fairness drift over time? I track metrics like precision, recall, or false negative rate across subgroups. If gaps widen between groups, fairness drift is occurring. This ensures models stay equitable post-deployment. What's the difference between monitoring and auditing in AI? Monitoring is real-time tracking of performance, while auditing is periodic, deeper inspection of data, processes, and compliance. Both are needed, monitoring for speed, auditing for rigor. How do you prevent silent failures in AI systems? By setting up automated alerts for drift, unusual predictions, or missing data flows. Redundancy in checks and clear escalation paths ensure problems surface quickly instead of slipping through. What is data quality monitoring, and how does it relate to AI performance? It's the continuous validation of data feeds, checking for missingness, duplicates, or inconsistent formats. Poor quality inputs directly degrade model predictions, so monitoring data is as important as monitoring outputs. How do you explain drift to non-technical stakeholders? I'd say the world changes, but the model learned from the past. Drift is when new data no longer looks like the old data, so predictions get less accurate. Monitoring catches these changes early. How do you decide when a model needs retraining? If drift exceeds thresholds, performance drops below KPIs, or errors cluster in subgroups, retraining is needed. Retraining is not on a fixed schedule. It's triggered by evidence from monitoring. What is governance in AI data management? Governance is the set of policies, roles, and processes that ensure data is accurate, ethical, secure, and compliant. It makes AI systems transparent, auditable, and aligned with regulations. How does lineage tracking support AI governance? Lineage shows where data came from, how it was transformed, and how it was used. It ensures reproducibility, helps troubleshoot issues, and provides transparency for audits or regulators. What is the role of documentation in AI governance? Documentation records data sources, cleaning steps, assumptions, metrics, and known limitations. It ensures transparency, accountability, and trust in both the data and the model's use. How do you monitor ethical risks in AI data? By tracking subgroup performance, checking for biased labels, and auditing data sources. If certain groups are underrepresented or misclassified, ethical risks arise that analysts must flag. What is the difference between proactive and reactive monitoring? Proactive monitoring anticipates risks, setting alerts, defining thresholds, and simulating failures. Reactive monitoring responds to problems once they're reported. Strong AI governance requires both approaches. How do you monitor models that produce probabilities instead of labels? I track calibration. Do predicted probabilities match observed outcomes? For example, when the model says 80% likely, the event should occur roughly 8 in 10 times. Poor calibration signals drift or misalignment. How does drift affect fairness in AI? Drift can disproportionately harm minority groups. For example, if new data skews toward one region, predictions for underrepresented groups degrade faster. Monitoring subgroup drift ensures fairness is preserved. What are shadow deployments and how do they help with monitoring? A shadow deployment runs the new model alongside the old one, without impacting production. Analysts compare outputs to detect drift or unexpected behaviors before a full rollout. How does governance support regulatory compliance in AI? Governance enforces data privacy, consent tracking, and audit trails. This ensures compliance with laws like GDPR or HIPAA and prevents fines or reputational damage. What is continuous monitoring and why is it necessary in AI? Continuous monitoring means tracking metrics in real time, not just at intervals. Since environments change quickly, continuous monitoring ensures immediate detection of issues before they escalate. What is the data analyst's role in AI governance? A data analyst ensures that data pipelines are reliable, metrics are trustworthy, drift is detected early, and fairness is continuously evaluated. They act as the bridge between data, models, and ethical business use. What is bias in AI datasets? Bias means systematic distortion that favors certain outcomes or groups. For example, if historical hiring data overrepresents one gender, the AI model may unfairly replicate that pattern. Detecting and mitigating bias is a core responsibility for analysts. How does sampling bias impact AI models? If samples don't reflect the target population, models will fail in production. For instance, training speech recognition only on urban accents creates bias against rural speakers. Analysts check distributions to ensure representativeness. What is label bias and why is it dangerous? Label bias happens when annotations reflect subjective or inconsistent judgments. In sentiment analysis, one annotator may label sarcasm as positive while another calls it negative. This misguides AI into flawed decision-making. How do you detect bias during EDA for AI? I compare feature and label distributions across demographic or contextual groups. If certain groups are underrepresented or show higher error rates, that's a bias signal requiring mitigation before training. What is algorithmic bias, and how does it relate to data bias? Algorithmic bias arises when biased data leads the model to unfair conclusions. If inputs are unbalanced, the algorithm learns those patterns. In short, biased data, biased outputs. What is fairness in AI, and why is it important? Fairness means model outcomes are consistent and equitable across groups. It's important to avoid discrimination, maintain trust, and meet ethical and legal standards. Without fairness, AI risks harm and loss of credibility. What are common fairness metrics in AI? Examples include demographic parity, equal outcomes across groups, equalized odds, equal false positive or negative rates, and predictive parity, equal accuracy. Analysts evaluate these to ensure fairness isn't compromised. How does proxy bias occur in AI datasets? Proxy bias arises when neutral variables indirectly encode sensitive attributes. For example, ZIP codes may act as proxies for race or income, creating unfair outcomes. Analysts test correlations to detect such issues. How do you balance fairness with business objectives? It's about trade-offs. I work with stakeholders to define acceptable thresholds where fairness is improved without completely sacrificing performance. Documenting trade-offs makes the process transparent and ethical. How do you explain bias issues to non-technical stakeholders? I use clear examples. Our model works well overall, but is 20% less accurate for older customers. If uncorrected, that group may get worse service. Framing bias in business terms drives action. What is ethical data analysis? It's analyzing data responsibly by ensuring privacy, fairness, transparency, and accountability. Ethical analysis prioritizes human impact over just technical performance. How do you ensure privacy when analyzing AI datasets? By anonymizing identifiers, using aggregation, and minimizing unnecessary collection. Analysts also apply privacy regulations like GDPR and HIPAA to safeguard individuals' data rights. What is informed consent in AI data collection? It means individuals understand what data is collected, how it will be used, and agree to that use. Collecting data without consent undermines both ethics and legality. How do you mitigate bias once it's detected in AI data? Options include resampling underrepresented groups, reweighting data, collecting new samples, or adjusting thresholds. Documentation ensures mitigation steps are transparent and reproducible. What is cultural bias in AI data, and why does it matter? Cultural bias occurs when data reflects only one culture's values, norms, or behaviors. For example, facial recognition trained mainly on Western faces fails on others. Addressing it ensures AI systems are global and inclusive. How do you ensure inclusivity in AI data collection? By designing sampling strategies that cover diverse populations, languages, devices, and geographies. Inclusivity ensures models don't fail for underrepresented users. How do you monitor fairness over time after deployment? I track metrics by subgroup, like recall or precision across demographics. If gaps widen, it signals fairness drift. Continuous monitoring prevents hidden bias from creeping back. What is transparency in AI and why is it valuable? Transparency means documenting datasets, methods, and assumptions so decisions can be explained. It builds trust with regulators, users, and business leaders and ensures accountability. How do you detect discriminatory outcomes in AI systems? By auditing predictions and comparing error rates across sensitive groups. If one group systematically receives worse outcomes, that's discrimination requiring remediation. What is anonymization, and how does it differ from pseudonymization? Anonymization permanently removes identifiers so individuals can't be traced. Pseudonymization replaces identifiers with codes that can be reversed with extra information. Both protect privacy, but anonymization is stronger. How do visualizations introduce bias? Through misleading scales, truncated axes, cherry-picked timeframes, or colors that exaggerate effects. Analysts must ensure visuals are fair, transparent, and not manipulative. What should a data analyst do if findings conflict with stakeholder expectations? Remain objective. Present evidence clearly, explain the implications, and suggest next steps. Hiding or altering findings for convenience would be unethical. How can organizations institutionalize fairness in AI? By creating governance frameworks, fairness guidelines, bias checklists, and routine audits. Embedding fairness in processes makes it a standard, not an afterthought. What are the risks of ignoring ethics in AI data analysis? Ignoring ethics can cause reputational damage, legal penalties, customer distrust, and systemic harm to affected groups. Ethical lapses erode trust and undermine AI adoption. What is the data analyst's role in ensuring ethical AI? Analysts serve as gatekeepers, ensuring datasets are representative, metrics are fair, biases are detected, and results are communicated transparently. They bridge technical models with ethical responsibility. How would you analyze data for a recommendation system? I'd start with user item interaction data, clicks, views, purchases. Then I'd run EDA to detect sparsity, bias toward popular items, and cold start issues. Ensuring balanced coverage across users and items makes recommendations more inclusive and reliable. In fraud detection AI, what role does a data analyst play? I'd explore transaction data for unusual amounts, geolocation mismatches, or rapid activity bursts. Outliers often reveal fraud, but I'd also validate that legitimate rare behaviors aren't flagged unfairly. Balancing false positives versus false negatives is critical here. How would you evaluate chatbot logs to improve AI models? I'd categorize conversations by intent, success versus failure, and common fallback triggers. Identifying frequent misunderstandings or unanswered queries helps refine training data and improve response accuracy. How do you analyze healthcare data for an AI diagnostic system? I'd check for class imbalance between healthy versus disease cases, ensure demographic coverage, and validate label accuracy from medical experts. Ethical stakes are high, so fairness and accuracy across patient groups are critical. In a hiring AI system, how would you detect bias? I'd compare model predictions and outcomes across gender, ethnicity, or age groups. If certain groups face higher false rejection rates, that signals bias. I'd flag this and recommend retraining with more representative data. How would you handle seasonality in AI demand forecasting? I decompose historical data into trend, seasonality, and residuals. Features like holiday flags or month of year improve forecasting accuracy, ensuring the AI captures real-world cycles instead of mistaking them for drift. How would you analyze data for a sentiment analysis model? I'd review label distributions across positive, negative, and neutral categories. I'd also check linguistic diversity, slang, sarcasm, multiple languages. Without this, the model risks poor generalization. A loan approval AI shows higher rejection for younger applicants. What would you do? I'd analyze feature distributions like income, credit history, and repayment. If age is acting as a proxy, I'd recommend removing or adjusting related features. Fairness audits ensure the system doesn't discriminate. How do you evaluate drift in an AI-powered ad targeting system? I'd track shifts in user behavior, new interests, device types, or click patterns. If ads stop matching users, drift has occurred. Continuous monitoring ensures campaigns stay effective. How would you test fairness in a facial recognition AI? I'd evaluate accuracy across subgroups, gender, skin tone, and age. If performance gaps are significant, the dataset likely lacks diversity. Collecting more balanced samples would be the first fix. In an e-commerce AI, how would you identify cross-selling opportunities? I'd analyze co-purchase patterns, frequent item sets, and basket analysis. For example, people who buy a laptop often buy a mouse. These insights improve recommendation models and revenue. A voice recognition AI struggles with accents. What steps would you take? I'd analyze audio samples across accent groups, check performance disparities, and flag underrepresented accents. Collecting more diverse data improves inclusivity and reduces bias. How would you evaluate AI for credit scoring fairness? I'd compare predicted default rates across protected groups, ensuring consistent thresholds. If disparities exist, features acting as proxies for sensitive attributes must be reviewed and adjusted. How would you analyze AI performance in supply chain optimization? I'd track prediction accuracy for demand versus actual demand, review errors by region or product, and test robustness during disruptions like strikes or weather. Insights guide model retraining. In a spam detection AI, what metrics matter most? Precision matters. False positives frustrate users, but recall is also key to block actual spam. I'd balance both with F1 score, ensuring users get value without losing important emails. How do you evaluate churn prediction models? I'd measure recall. Catching actual churners early is crucial. I'd also analyze feature importance, e.g., usage frequency, complaints, and segment results by demographics to ensure fairness in retention strategies. In a healthcare AI predicting readmission, how do you validate data? I'd check patient history completeness, demographic representation, and label accuracy. Ethical analysis ensures models don't unfairly penalize vulnerable groups like the elderly or low-income patients. How do you analyze AI for personalized learning platforms? I'd review engagement logs, question difficulty versus success, and adaptation speed across learners. If the system works better for certain demographics, that signals a fairness gap. How would you test robustness of an AI translation system? I'd evaluate accuracy across languages, dialects, and slang. EDA of test sets ensures coverage. I'd also analyze errors to spot cultural misinterpretations or offensive translations. How would you analyze fairness in an AI-powered insurance pricing system? I'd compare premium predictions across demographics, ensuring differences reflect true risk factors, not proxies like ZIP codes. Bias here can cause serious ethical and regulatory issues. How do you evaluate AI in predictive maintenance for factories? I'd analyze sensor logs, failure patterns, and environmental conditions. Outlier analysis helps catch rare failure modes. Model evaluation must consider recall to avoid costly missed failures. In a recommendation AI, how do you prevent popularity bias? I'd measure recommendation diversity and check if niche items are being ignored. Popularity bias makes systems boring and unfair. Balancing long-tail items improves fairness and user satisfaction. How do you analyze AI in financial trading? I'd evaluate predictions against actual returns, volatility, and risk metrics like Sharpe ratio. I'd also check performance during different market conditions, ensuring the model isn't overfit to one regime. How would you use cohort analysis to evaluate AI systems? By grouping users by sign-up date, geography, or behavior, then analyzing model performance over time. Cohorts reveal if AI works consistently across lifecycle stages. What is the data analyst's role in real-world AI deployment? The analyst validates data, monitors drift, ensures fairness, and translates AI outputs into business insights. They act as the safeguard, making sure AI adds value without causing harm. That wraps up our 200 data analyst interview questions for AI projects. By mastering these, you'll not only ace your interviews, but also gain the mindset to work confidently with AI systems in production. If you found this video valuable, make sure to like, subscribe, and hit the bell icon so you don't miss future interview prep guides. Share this with friends or colleagues who are also preparing, and drop a comment with the next role you'd like us to cover. Until then, stay data-driven, stay AI ready, and I'll see you in the next video.